All right, so last time we went through being able to draw ray diagrams for convex concave mirrors. We were able to look at use equation involving the focal point length, the distance the object is from the mirror, to figure out how far away the distance the image forms from the mirror. And then using that information, we were able to figure out the magnification of the mirror lens, with the object at that specific distance. And we were able to figure out how high the image is. Today we're going to start looking at ray diagram, ray tracing for lenses. So we have two types of lenses named just like the mirrors. We have a convex and a concave lens. You'll sometimes hear them called converging or diverging lenses, and that'll make more sense here in just a little bit. Really, the convex part, it's typically a double convex because it's curved on both sides, and it's double concave. It's concave on both sides. Because you can't have these things where they are just convex or concave on one side, but you have to use different. That's more of a refraction problem like Snell's law than it is ray tracing, so we don't really talk about it. Fix that quick. So ray tracing with these things, I would say they're a little bit tougher than mirrors just because we now have focal points on both sides of the lenses because it doesn't matter if you flip a lens, it works the same. And with that, we can still talk about there being a center of curvature, for the mirrors, for the lenses. They're still just twice the focal length. But when it comes to the ray diagramming, they tend to not be useful. The center of curvature points were important for mirrors, but typically what tends to be more important for lenses is the midpoint. So with all of the lenses, what I do before I start is I draw a line, kind of goes through the middle of them. I'll even draw it a little bit bigger than the lens just in case I didn't draw the lenses big enough. So now everything's in place. We can start doing our ray diagram tracing. So let's start with, so once again, I have my pencil-shaped object there. Good enough. Object. So now with my parallel ray, it's going to start being parallel to the axis. Now keep in mind, normally when a light ray would hit the lens, it's going to refract because it's moving from one medium to another, changing speed, causing it to bend. And then it's going to refract again when it goes and leaves the lens. And we could draw in the change in angle each time. But I think these rules allow us to approximate that well enough where we don't need to care about the individual instances of the refraction. Okay, so starting off with parallel to the axis. Now I'm going to go through F. So with lenses, the light rays themselves are going to go through the lens. So I'm going to stay I'm going to stay a solid line on this side. And I'm going to aim for this F right here. So go through F. Now, though, I do need to draw a dotted line kind of on this side of the lens. Okay, that could be important for some of the diagrams we have to draw. So I'm just going to make sure that's in there. Now when we get to the second one, the focal point ray, this one's going to go through F. It's going to be on the F on the same side of the object though. So before the lens or the mirror, it's going to go through F. So we're going to go through this point right here. So if I draw that quick, that line goes there. It's a good thing we'll pretend that the lens is actually bigger than what I drew there. So once again, when that light ray reaches the lens, it's then going to go parallel to the axis. So now it's going to go kind of off that way and dotted line on this side. Should probably find a new program to do this with. All right. So right away we can kind of see our dashed lines are never ever going to meet. But we can already see our solid lines have met on one side. Good enough. All right, so now I can go to the third ray. Now for mirrors, we used to call it the center of curvature ray because we were worried about those C points. With lenses, we care more about the midpoint of the lens. So the middle of the lens that we can kind of see where that line I drew through the middle of the lens meets up with the axis. So now for that third one, I'm going to go through the midpoint. We could also call this C if we wanted. And then really it's just going to extend on both sides. So if I just kind of go through and go that. Like that. Sweet. That actually worked out for me. Okay, and we can even say that that ray goes off that way. Once again, we can see there's no convergence on this side of our rays, but we do have a convergence, I'm approximating a little bit there, over on this side. We can kind of see that our image is going to be, draw it kind of like that. Our image is going to be quite a bit bigger. We can already see it's taller than the object. The other thing we notice is that it's an upside down, it's an inverted image. And in class and stuff, I'll give you some ideas of when you know of how to indicate things are inverted, stuff like that. All right, so right now we can even see that our magnification is going to be greater than 1 since our image is bigger. We can even see originally our object distance was in between C and F here. Here we can see the image formed was outside of C. So the image distance is even going to be bigger. All right, so let's go through this process one more time, looking at that diverging lens there. So starting off with parallel ray, parallel to the axis. So let's go through, let's say, get to that middle point. Now it's going to go through F. All right, so this is where things get a little bit tricky. You might need to make a note of it somewhere. The F that the diverging ray is going to aim for is this F right here. So keep in mind though, so this is where like a ruler would be really good. We're drawing a line right here. That light ray is just over on that side, so we're going to say it's going to go about like yonder. And then I've got a dashed line kind of going there. And let's extend that dashed line out a bit. Okay, so we're good so far. Now for the focal point, we're going to go through F, and then we're going to go parallel to the axis. In this case, the F we're aiming for is the one over here. So essentially for convex, the first F, if my object was on the left, my first F was on the right, the second F was on the left. Here we're flipping it. The first F I'm aiming for is the one on the left. The second F I'm worried about is the one on the right. So in this case, so I'm on the blue, I need to make it about right there. So we're going to go to about, got a little wobbly there, but that's all right. So now we're going to go parallel to the axis. Dotted line on this side. That should be good enough. So we can already see that the actual light rays themselves, they're diverging, which is kind of where so convex lenses are also named converging, concave, diverging. The real light rays we can see are moving away from each other. And then the kind of their virtual rays, if you will, are, hopefully we're going to see some matching up there. So the last ray we got is just through the midpoint, which is right here. So we just kind of take this, draw it through that midpoint. And keep in mind, it's also going to form a dotted line on this side of it, but I can't really draw that in. So these three rays here, separated. And then the dotted lines all kind of met up right here. So I can actually draw in my image here. And we got a completely opposite effect with the concave lens that we did with the convex lens. So the concave lens, we ended up with an upright image. It was in the same direction as our object. It was a virtual image because it wasn't actually formed by the light rays themselves. They were formed by kind of this virtual, what would we see with our eye kind of thing. And it was smaller. The image was closer to the mirror, closer to the lens, and it was smaller. That's a good way that we can approximate it. So I would say convex and concave mirrors, they just do opposite things from each other. But the practice problems you're going to go through are going to deal with how does that image change when we move that object? Like when the object's outside of C, when it's at C, in between C and F, which is what we did for both of these, when it's at the focal point, and then when it's in between the lens and the focal point. And that's going to give you different results. You're going to produce different images with that. Keep in mind those magnification equations, the focal point equations, those work the exact same. The only thing that's going to be different is when your F is positive and your I is positive. And those I'll be giving to you right now. So in this case, we're going to say that, get out of here sidebar thing. So F is positive for converging lenses. And that means that your F is negative for diverging lenses. And keep in mind, converging, convex, diverging, concave. The other thing that's going to be a little bit different is just our M's. So magnification is positive, because keep in mind, magnification, if it was less than 1, your object got smaller. If your magnification was greater than 1, the image was bigger than the object. Well, now we're going to have signs involved with our magnifications. And if our magnification is positive, our image was upright. So for upright images. Sorry about the handwriting there. And that means our magnification is negative for inverted images. One misconception is just because your magnification is negative doesn't mean your object's getting smaller. It just means the image is going to be flipped. It's going to be upside down. That's really all that means. Your image distances, so DI, the image distance is positive if it's real. So that means the solid lines match up. And so your DI is negative if it's a virtual image. That means it's created by the combination of dashed lines. And once again, your object distance is always, always, always positive. Those are going to be the big differences between mirrors and lenses, and you can use this kind of flesh out the notes you have. I think that's all I got. Good luck with the diagram practices.